Welcome in Tilco Advisors. We empower construction material manufacturers with cutting-edge digital solutions. And now, welcome to our podcast, where we share insights from the world of smart construction technologies.
Today, our mission is pretty laser-focused. We're investigating why a multi-trillion-dollar industry architecture, engineering, and construction still runs on documents that are, let's be honest, ancient history.
You mean the PDF and the spreadsheet?
Exactly. The PDF and the spreadsheet. Our big question today is, why is AEC so stuck in the past?
It's an almost unbelievable amount of inertia. When you look at other huge global manufacturing sectors, they're all being pushed and pushed hard.
By regulation, mostly.
By regulation, yeah. Pushed toward machine-readable, structured data, driven by APIs. And yet, construction just seems uniquely comfortable in what we're calling the PDF comfort zone.
That's the perfect term for it. So our deep dive today is going to look at that persistence, that reliance on unstructured data, and then we're going to contrast it with this aggressive regulatory shift that's happening outside the industry.
Specifically things like the digital product passport,
which demands the exact opposite of a PDF.
It really does. So to set the stage, maybe we should quickly unpack that core tension. We're talking about two kinds of information here. First, you have unstructured data.
Oh.
And that's basically anything a machine can't easily interpret or process on its own. So think about those PDFs, the endless text in emails, project photos, videos.
Even comments in a Word doc.
Yeah, exactly. A human has to read it, has to synthesize it.
It's the stuff that needs manual labor just to become usable input.
Precisely. And then on the other side, you have structured data. This follows a very specific predefined format. It makes it instantly readable and, more importantly, actionable by machines.
So in construction, what are the ideal examples?
Well, the ideal examples are things like well-defined IFC files, and we have to stress they're data schemas, not just file formats, or, a properly structured database system that lets you exchange information automatically through an API.
It's like the difference between getting a scanned paper invoice versus just having the XML data feed directly into your accounting software.
That's the perfect analogy. One is a picture of information, the other is the information.
Okay, let's get into the core of it then. Why AEC is still so obsessed with the document. We looked at a really critical study on the Irish construction industry, and it shows these problems aren't just small kinks. They're like foundational roadblocks.
Yeah, and the problem really starts at the top. The study noted that the senior decision makers, we're talking financial directors, operational heads, they tend to view digital processes.
Like BIM, building information modeling.
Right, like BIM. They see it as nothing more than an extra cost and overcomplication.
It's that classic short-term thinking, isn't it? I mean, they're looking backward, leaning on their, 30 years of experience building things with paper, instead of looking forward maybe 3 years at what's coming down the line.
And that mindset is just incredibly damaging. The real insight from the study is that these firms are prioritizing managing past liabilities, what they know, what they're comfortable with, over mitigating future risk.
A cheaper past over a compliant future.
Well said. And even when they do invest in the software, you then run into this massive proficiency gap.
So you have the tools, but not the skill to use them.
Absolutely. The whole point of BIM, the real benefits like reducing errors or cutting costs, it all relies on the whole team being extremely proficient, not just one or two specialists in a back room.
And if that skills gap is there, the whole thing just breaks down.
It does. Errors still happen, and then the senior directors get to feel justified and say, see, I told you it was just an extra cost.
And that just spirals, right? We see in the source that it leads to misunderstanding even the most basic digital standards. They mention that IFC industry foundation classes is often seen as merely a file format.
Not as a data schema.
Which is a huge difference.
It's a fundamental failure. If you think it's just a file, you'll treat it like a PDF attachment in an email. But if you understand it's a schema, a structured roadmap for the data, then you get its power.
And that lack of understanding goes even further. The study found that when it comes to things like digital twins, clients just don't understand this and they don't really want it.
And why would you spend millions on something your paying client doesn't even value?
That leads perfectly into maybe the most shocking anecdote from the sources. It's about the practical reality of data handover, and it completely undermines this whole push for structure.
I think I know the one you mean, the pharmaceutical facility.
Yes. So you have a client, a big one. They issue a high-level request, an exchange information requirement, an EIR, and it demands a full digital twin with Kobe, all the structured asset data, for this massive facility worth over 100 million euros.
So that's the formal contractual document. It sets the bar extremely high for what structured data they expect.
But the people who actually have to run the building, the facility management team, the boots on the ground, they step in at the very end. And they say, hold on, that full model, it's too complex. We just want a simple Excel sheet with 10 parameters.
Unbelievable. You have this incredibly expensive structured data set that took months, maybe years of work.
And it gets thrown out for a spreadsheet.
That operational mismatch, that chasm between the contractual expectation and the day-to-day need, it just fuels that retreat back to unstructured data. It confirms for all the cynics that structured models are just bureaucratic noise.
And this breakdown, this retreat to Excel, it gets even worse because of another huge problem, the IP dilemma. Intellectual property.
Oh, this is the real industrial self-sabotage. It's wild. When design teams issue their models, they often intentionally strip out information. The quote is, all the data before you share it.
Why? To protect their IP?
To protect their IP, so they only share the basic geometry. And that action renders the data-rich model they were paid to create completely useless for anyone downstream.
Wait, hold on. So let me get this straight. Firms are paid to create sophisticated data-rich models, and then they intentionally destroy the value in those models before they hand them over.
To protect their commercial interests, yes, it's a massive trust issue, a fear of data leakage.
But the whole point of BIM is collaborative data flow. So when the data gets stripped out of the structured environment, where does all the important communication go?
Into the email trap.
Of course.
Exactly. All the key coordination gets shunted into email or, instant messaging like Teams. People in the study actually confess they do this because they're genuinely worried that important information gets lost in the common data process.
The CDE, the common data environment, that's supposed to be the single source of truth, the one structured central place for everything.
It's supposed to be.
But isn't the CDE itself sometimes the problem? I mean, if the user experience is clunky or slow, doesn't that just encourage people to send a quick email with an attachment?
That is absolutely right. The structured system has to be easier and faster than the unstructured workaround. If it's not, critical information, a last-minute material change, for instance, ends up copied in 100 different inboxes, completely invisible to the formal system. That is the reality of the PDF comfort zone.
So we've got an industry stuck in this inertia. It's plagued by cultural barriers, IP fears, and just a preference for scribbling on a PDF. But what happens when that external pressure gets too big to ignore? And this is where it gets really interesting.
Right, because now we shift our focus from construction's inertia to the regulatory catalyst that's shaking up global supply chains everywhere, the Digital Product Passport, or DPP.
And this is the mandatory driver of data structure.
It is. And this isn't just about construction materials, right? This is a massive EU mandate. It's hitting everything from electronics and batteries to textiles and, crucially for our conversation, construction products.
And the DPP is designed to be the exact opposite of a PDF.
The definitive opposite. The amendments to the Construction Products Regulation, which were approved in May 2024, they mandate that the DPP for every single product has to include critical, technical, and environmental data.
And it specifically requires an API-first approach for product information, doesn't it?
Yes. The requirements are, they're non-negotiable. The data must be machine-readable, structured, and searchable. It has to be based on open, interoperable formats, specifically to avoid being locked into one vendor's system. And the content is detailed. Manufacturers have to link official documents like declarations of performance, environmental product declarations.
EPDs.
EPDs, yeah. This is the global shift from passive documents to active, live, machine-readable data streams.
So to understand just how huge this transition is, we looked at a readiness assessment. It wasn't in construction, but in the textile industry in the global south.
And what's fascinating is how the preparation for this DPP is so strongly correlated with the size of the company. The large and medium-sized firms, they show a much greater capacity, but the micro and small firms are lagging significantly.
And the reason is, let me guess, spreadsheets.
You guessed it. Over 50% of the firms in that supply chain still rely on unstructured data formats, mostly Excel.
The spreadsheet strikes again. It proves how persistent it is across all of manufacturing, not just construction. And Excel just can't support the kind of traceable, machine-readable data the DPP demands. It doesn't have that underlying structure.
And this creates what the study calls the intent capability gap. You have a lot of firms, about 55%, who fully intend to comply. They're planning to implement DPP systems in-house.
But they can't actually do it.
Well, the reality is only about a third of them have the required technical capabilities. They don't know how to handle data exchange protocols or the machine-readable formats you need for that API connection. They want to comply, but they fundamentally underestimate the shift.
And this gap must create a huge regulatory headache, the traceability failure.
Absolutely. The data shows that while information depth, it increases along the value chain.
So the company making the final shirt has more total data.
Right. But the upstream actors, the raw material producers, the yarn spinners, they systematically limit the traceability.
Which means you can't track the material composition, you can't track chemicals of concern, you can't provide those environmental metrics like water or energy use, because the data just isn't there in a standard format at the source.
And if you can't verify the integrity of the information at the fiber level, the final product, whether it's a t-shirt or a construction product, it simply cannot comply with the DPP. This is the non-negotiable force that product suppliers in construction are facing right now.
So if regulation is mandating structure, standardization, and API access, how does construction respond? It has to find a way to digitize this product information. And the industry has come up with something called product data templates, PDTs.
PDTs are the industry's design solution for this. They're defined by standards, like EN ISO 23387, as standardized data structures that describe the characteristics of construction products.
So instead of a manufacturer just sending you a PDF brochure, they give you data that fits into a template with machine-readable fields for things like, fire resistance or embodied carbon.
That's the starting point. But the real power is in the standardization ecosystem behind them. These PDTs, they aren't just isolated spreadsheets. They're designed to connect directly to IFC for the geometry, and they align with the new construction products regulation.
But to get beyond just data entry, you need a language that any software can recognize automatically, right? Regardless of country or human language.
That's where it gets really technical and really powerful. PDTs define property attributes using something called a globally unique identifier, a GUI.
A GID.
This is maybe the most critical detail. The GUID is this long, unique string of numbers and letters. It's like a digital fingerprint that's permanently assigned to a specific property, like thermal conductivity or door height.
Okay, so if a German software system, a French database, and a US BIM model all need to check the thermal conductivity of a window, they're not looking for different words in different languages.
No, they're all looking for the exact same GUID.
The same digital fingerprint.
Exactly. It ensures global uniqueness. And these attributes link to interconnected data dictionaries. This is what creates the foundation for automated data exchange. It's the only way to satisfy the DPP. It's what turns a static model into a live data asset.
And we found a great example of this in practice, a national initiative, PDTs.pt in Portugal, that shows the actual pathway from this standard to real API integration.
This initiative, they're actively creating these data models for common construction items, doors, boilers, gypsum board, all based on those ISO standards. And crucially, they understand that the final output cannot be a document.
So how are they making that API connection happen?
Their whole goal is to provide open, standardized PDT data in machine-readable formats like JSON, and then make it accessible via an API. So any design software, any facility management tool, any regulatory system can just pull the current validated product data. It can see the GIs, it can reference the legal documents. It's the transition point.
From the chaotic email trap to a centralized, automated data stream.
But it requires structure, standardization, and openness.
The three things we already established the AEC industry struggles with most.
Precisely. The technology is there. The culture isn't.
So, to bring it all back to our central theme, from PDF to API, why construction stays stuck, we've really laid out the core conflict. You have an industry held back not by the technology itself, but by this deep cultural inertia, this belief that digital tools are extra costs.
And by IP fears that lead to firms literally deleting value from their models, and this deep-seated reliance on informal data flows like email.
Meanwhile, the rest of the manufacturing world is facing these massive regulatory deadlines like the Digital Product Passport. It's mandating an API-first future. The data must be structured, searchable, and machine-readable, whether you're ready or not.
And the technical solution, it exists. Initiatives like the PDTs prove that the infrastructure can be built. You can use APIs and GIs as a universal language.
So the key question isn't whether the tech works.
No. The question is whether the industry will embrace the change needed to use it. This shift from PDF to API requires a fundamental change in power dynamics. When data is hidden in a PDF, the large firm controls the flow. But when data is open and structured via an API, there's a real risk that micro and small firms, the ones without the resources to build their own systems, could get systematically excluded from future value chains if they can't connect.
So the comfort of the PDF protects the existing hierarchies. It avoids accountability.
It does. So the final question for AEC is this. Can the industry overcome its comfort zone and standardize its information flow? Can it make transparent data sharing the norm, not the exception? Or will it just wait until external regulation forces its hand and financially sidelines anyone who isn't compliant?
A potent question to leave you with as you consider where your own firm falls on that PDF to API spectrum. Thank you for joining us for this deep dive.
That's it for today's episode. We hope you enjoyed exploring how digital workflows are transforming the construction industry. Don't forget to subscribe and join us next time for more insights into building smarter. Looking for more knowledge and inspiration? Head over to our website. You'll find everything you need to keep building smarter.